Okay, so welcome again. We were talking about the quartile, right? Quartile, percentile, median, right? So quartile divides the data set into two parts. Okay, four parts. Four parts means quartile 1, quartile 2, quartile 3, quartile 4. Okay, if you have 100 data, it will create 25, 25, 25, 25, 4 25s, right? Interquartile range. Interquartile range is Q3 minus Q1. Okay, 1 second. Okay, so and we ended up drawing box plot, right? So box plot talks about your interquartile. So box is your IQR, interquartile range, right? And the handle is your minimum and maximum, which is Q0 or Q4. And based on the data, it will also mark outliers. So box plot is the only plot which will also mark outliers, right? Okay. Now, okay, so we discussed this. We discussed this example, and we also discussed about variance and standard deviation. What is variance? Variance is another metric, right, which captures the deviation from the mean. Right? We are capturing the deviation from the mean. We calculate average minus each value, right? Mean is average. So we calculate, okay, we learn how to calculate, right? So we first do the minus average value minus each value, right? Average is, let's say, what you expect, right? But you got something else. So that average minus something else is the deviation, right? Variance. But what we saw that some values will be minus, some will be plus. So they are getting equated to 0, right? So if you do not want, of course, minus doesn't mean any sense. If I ask you how much is the deviation, you will tell me the difference. You will not tell me whether plus or minus, right? Before or after is still their deviation. So we do square. We have to convert negative into positive. So to convert negative numbers into positive, we do square. And we do the square and we add all them together. So that's why you see graph, formula here. It is squaring, okay, and then adding them together. And that is for total deviation. And you have to find per data, right? So if there's a process which has 100 deviation, 100 variance, another process has 200, which is better? No, we can't say. We don't know how many elements is there, right? Okay, total count, yeah. So maybe this 100 is based on 10 data and 200 is based on 100 data. So, of course, 200 is better in that case, right? So that's how to calculate deviation per unit, per data. So divide entire thing by n. That is also called as variance. Okay. But now the problem here is, since we did square, we are comparing non-square versus square. Right? So what we do is we take the square root. So square root of variance is standard deviation. Okay, that's what we discussed. Then sometimes you have population data, sometimes you have sample data. Population data means you have entire data. Okay, if you have 10,000 rows, 1 lakh rows, 10 lakhs rows, you have all the data with you. So there, this formula holds good. But where you have sample variance, that means you don't have access to entire data. You have you have access to only sample data, right? Maybe 50,000 out of 1 crore, right? So in that case, when you you calculate exact same thing, okay? But problem there is your variance will be higher than what you have calculated because there's more chances of being error. So what formula says is, okay, since there is chance of error, let me introduce error in the formula itself. So that's why you are doing n minus 1. We are increasing the variance because we don't have access to lot of data. So we want to increase the variance. We want to increase the error component. Okay. Yeah. Election process is also same process. Okay. You cannot have access to so many data set. Since you cannot have access to so many data set, okay, so you take simple data. I mean, you take 20,000 or whatever, right? And then you introduce the error in it. You introduce the error. Yes. Okay. So that is called standard deviation. What we just did is standard deviation. Okay. So now you're talking about median, quintiles, deciles, okay, percentile. We know that we did this. Okay, now you tell me with, so here we have seen how many metric? We have seen range, IQR, interquartile range, variance, and standard deviation. Which do you think is best? Which will give us more result? IQR is better than range. So range you drop, IQR is better. Between variance and standard deviation is better. Okay, so you drop variance also. Now between IQR and standard deviation, which is better? Okay, so yes, standard deviation is better because here you are taking, in IQR only you're looking at the first and last, correct? But in standard deviation, yeah, every data we are using in calculation, right? So that's why standard deviation turns out to be better, but IQR also has its own use. So we tend to use IQR and standard deviation. Okay. Now, when you draw this curve, okay, this center point is what? Peak, but what do you call this? This is your
Median.
mode, right?
Mode.
Peak
Okay.
is mode. Peak is always mode, right? But if your data is normal, this is normal. So mean and median will also be at here only. So your peak talks about same mean, median, mode. So these three data that you see, okay, we have not, so these all three are normal. That means it does not have skewness. There's no skewness in it. If there's no skewness in it, your mean, median, mode are all three same. Skewness, positive skewed, negative skewed, tail, right? So now if you take this here, the mean, median, mode, the tall is, all three graph has same point tall, right? They are high at same point. That means mean, median, mode of all three graphs is same at same point. So did you understand? Mean, median, mode of all three data set is same. Okay, if mean of first one is 50, mode is also 50, median is also 50. Second data set also it is 50, third is also 50. Okay, so all three have same mean, median, mode. But then how does it, how do we analyze it? Okay, how do we make sure that, we are able to understand data better? Which is better? Which is better here? Among three graphs, which one is better? The one which has less deviation. The deviation you see is the standard deviation. Okay, one that has least deviation. One that has least deviation is better, right? We don't want deviation in the process. We don't want deviation in the process, right? Which has least deviation? Yes, this one has the least deviation. This is the deviation. Okay, we want this curve to be thin. Okay, widespread curve means there is a lot more values, deviation is high. So even though mean, median, mode is same for all the three, okay, so see, it's like first one is like, I tell you class will start at 7, but I come at 6:45, 7:15. Second case is like I come at 6:30 and 7:30. Third one is like coming at 6 o'clock and 8 o'clock. So average of all the data set is 7 only. Perfect. Whatever we want. But variance is high. Deviation is high. Right? So when the curve is thin, that means deviation is less and this process is good. We call them as leptokurtic. Leptokurtic is one that is thin with thin means less deviation. The standard deviation is less. Mesokurtic, okay, better than platykurtic, but not as good as leptokurtic. Okay, so this is how this is called kurtosis. Okay, kurtosis means this. Okay, and okay, you can read through this. I think already shared this file with you, right? So so again, see here, this is the graph. Okay, if you see here, standard deviation here. Okay, see, what is the mean of this graph? Tell me. I'm asking you this graph. What is the mean value? Tell me the value.
100.
100. Yes, it is 100. Right? And what is the mean of this? How do you know? Top. Yes, 100 is written here, right? So it is
100.
exactly below 100. Yes. So mean of both the process is 100. Okay, mean, median, mode, normal graph, right? So mean, median, mode of both the process is 100. But variance is, see, standard deviation is 5. That means, okay, it is ranging from 95 to 105. Here it is, standard deviation is 15. That means ranging from 85 to 100. Okay, so let me talk about it for some time. Okay, so let's say, okay, we said, okay, we draw x-axis. We draw x-axis. Okay, so this is your x-axis. Okay, now mean is what? 100. Mean is 100. Okay, standard deviation is 5. So you have standard deviation 5 here, means 95, 105. Okay, then you have 90, 110. Okay, 115, 85, so on, right? Now the graph will look something like this. Okay, this is your 100. This is your 100, right? So what it's, so this is dividing this data into 50% and 50%. Normal data, right? Normal graph, okay? So this line, median is what? 50%, isn't it? So since it is
Yes.
normal, your mean, median, mode is same, all 100. That means 100 is dividing this entire data set into 2 equal half. That's what it means when you say median. Median is dividing into 2 equal halves, right? So it is dividing into 2 equal halves, median. Okay. Now, so, okay, so from here till here, okay, it is 50. So this side also it will be 50, obviously. Total it is consist of 100%, right? So if this unit area is 1, this area will be 0.5 area and this is your 0.5 area, equal. Now if you look at standard deviation, this is called as 1 sigma. So standard deviation is 5. That means median, okay, minus 5 to plus 5 is called 1 sigma. And 1 sigma represents 95% of the data. So if this is your 100, this is 95, and this is your 105, that means this data, okay, is 95%. So tell me how much this will be, this part. There's the green part. Tell me, no, you don't know what is 95% half.
Half of 95%.
You don't know what is half of 95%? I'm asking, what is this? You're saying 5 plus 3 plus 2. I have to calculate in my mind, is it? What is 95 by 2?
It 47.
Yes,
Point.
yes, 47.5. Tell me, no, 47.5. Okay. If this is
Yeah.
47.5, then what is this blue area?
It's also 47.5.
Yes, this is also 47.5. So 1 sigma, that means standard deviation on left and right together will constitute 95%. Okay. And this is, okay, 95%. One standard deviation is always 95%. Look at this way. So if it is 15, this is, we calculate 5, right? If it is 15, and if this is 100, then the 95 will be at what point? 100 minus 15. What is that? 85 to 150. Okay. Yes. 1 sigma is always 95%. Okay. So what happens? That's why you see, in the other graph, when you are doing flat, when increasing the deviation, when deviation is less, it is taller. But if you reduce the deviation, it becomes less.
Spreaded.
Spread, yes. It becomes more. Because area has to be 95, height is not there. So it will take from side. Okay. So 1 sigma, okay, is always 95%. Okay. No. Sorry. I'm sorry, guys. Okay. It is not 95. I'm sorry. It is 68%. I'm sorry. I'm really sorry. It is 68%. Okay. 1 sigma is 68%. Okay. 68%. So if it is 68% total, then how much is green area? 34. Correct. A blue area is also
34 only.
Now when you take 2 sigma, okay, this is 95%. 2 sigma is 95%. Okay, what would be the value here? That means 100 minus 2 times of standard deviation and 100 plus 2 times of standard deviation. That means it is 90 to 110. 90 to 110 is 95%. Okay. And 3 sigma is 99%. So with 3 sigma, 99% of data is covered. Okay. Data into 3 parts means? No. Mean minus 3 times standard deviation and mean plus 3 times. So you have 5, right? 100 minus 5, 15 is from 85. So from 85 to 115. So this much will have 99% of the data set, 99% of the area. This is also called as empirical rule. Remember, 68, 95, 99. 68, 95, 99. Okay, we'll see later how to calculate. Later when we do machine learning, we'll see how to calculate using Z table. But for now, it is good enough. Okay, so let me go back to our, okay. Any question here? All good?
Yes, all good, sir.
Okay, let's go back to the, so this is called as 68, 95, 99, 99.7 rule. Okay, 3 sigma is 99.7%. 68, 95, 99. Okay, roughly, yeah, but it is actually 68.2, 95, 99.7. So remember this, 68, 95, 99.7. 68, 1 sigma on either side of mean will have 68% of the data. 2 sigma, other side of the mean, will have 95%. 3 sigma, other side of the mean, will have 99.7%. Okay, so this is what it is. Okay, so now when you go, this is what I just told you. Okay, so from minus 2 sigma to plus 2 sigma, it is 95. Minus 3 sigma to plus 3 sigma, it is 99.7. Okay. Okay. So if the mean is 50 and standard deviation is 10. So look at this. Mean is 50 and standard deviation is 10. This is what it means. 68% of the score, if the data obtained by a student of a class, if you take the data of a class and if you plot a histogram, you get a normal histogram. That means, okay, let's say if mean is 50 and standard deviation is 10, then 68% of the students will have marks between 40 and 60. 95% of the student will have marks between 30 and 70. Okay, 99.7% student will have marks between 20 and 80. Okay, this is what called empirical rule. Okay, now what is difference between mean, median, and standard deviation? We spoke about two set of metric: mean, median, mode, and IQR, standard deviation, right? So what does they give you? What does it tell you? What does they tell you? See, we have something called as accuracy and precision. What is different between accuracy and precision? How fast? Accuracy is not fast. Speed is fast. Accuracy is not fast.
How good the data.
How good the data is. And precision? When you say precisely 9.5 means what? Exactly 9.5. Okay. So precise is if you are doing it 10 times, how much are you getting same value? So for example, okay, accuracy is how often are you late, for example. Okay. So let's say if class time is 7 o'clock, okay, and I log in sometime at 6:45, sometimes 7:15. That is accuracy. Average, if you take, perfectly I'm logging at 7. Precise is, okay, if I log in every time at 7:15, 7:15, 7:15, 7:15, every time I'm logging at 7:15, the process is inaccurate. Process is inaccurate because I was supposed to log in at 7 o'clock, but I'm logging at 7:15. So my process is wrong. My process is not correct, but my process is precise. Every day sharp 7:15 I log in. So this is called precise, where when you read the data, when you perform some action, you get same result. Okay, exact same values every time. Not exact values, same values every time. Okay, if you are getting same values every time, we say precise. If you are measuring a pencil, okay, and every time it is coming at 8 inch, okay, so it is your, every time you're getting 8 inches, your measuring is precise. Okay, you're writing exam, every time you're getting 82%. You're precise, you're getting a precise score, 82. I mean, that means you are 82%, 82% candidate, kind of. Accuracy is sometimes you get 60, sometimes you get 90. 60, 90, average is always 70. You're not getting 70 every time. 70 means you're getting precise 70. But every time your average is 70. Sometimes you get high, sometimes you get low, but somehow you manage to get 70. So accuracy is 70, but your process is not precise. But if you get 70, 70, 70 every time, okay, then you're accurate also and precise also. So we want process to be what? We want a process to be accurate and precise. Now let's understand using this graph here. This is called accurate and precise. This is a your dartboard, and every time you want to hit at the center, correct? Your intention is to hit at the center. So what you're doing, you're hitting at the center, and every time you're hitting at the center. So average is also 100% because average is score of 10 or 100, whatever you call it, and every time you're getting 100 score. So it is precise, accurate and precise. Now here you see, every time you are hitting at position 10, 10, 10, 10, 10, you want 100, but you're getting 10, 10, 10, 10, 10. Accuracy is poor. You want 100, but you got 10. You want 100, but you got 10. So your accuracy is poor, but you're precise. Every time you're getting 10, 10, 10. Accurate, not precise. Okay. So sometimes you're getting 10, sometimes you're getting 70. 10, 70, 10, 70, 10, 70. Average is what you want. Average, I want 70%, I got 70%. Every time I get 70%. So I want 70, I got 70. So I'm accurate, but I'm not precise. Okay. And this is not accurate, not precise. You want 70, average, you're getting 20 average. The 20 also, it's sometimes 5, sometimes 30, sometimes 5, sometimes 30. So a process is not precise and not accurate. So when you look at a process, when you look at any analysis, data analysis, your data analysis can be accurate and precise, only accurate, neither. Right? Now you tell me, which is good, which is bad? First one is good, last one is very bad, right? So this is rank 1 and this is rank 2. Now between these two, which is better? Which do you think is rank 2 and rank 3? So we know this is rank 1, rank 2. Between these two, which one should be rank 2 and which one should be rank 3? No, precise is what is better. Always precise is better. Okay. Now let's say simple example. If every time I'm logging at 7:15, I can tell you guys, see, I'm not able to log in at 7. Let's change the class time to 7:15. Correct? So when you are measuring something precise, that means process is same. You are, so another example is, let's say you have a machine which cuts pipe. Okay. You have big pipe. Okay. Let's say you are a factory and you get requests from different companies for the precise size of pipe. Okay. And you have a cutter, big machine cutter, which can cut any pipe. So they'll send you the size, and based on the size you cut. Now, let's say your accurate and precise is, they want 5 feet for pipe, you cut exactly 5 feet and give it. They want 10 feet pipe, you cut 10 feet and you give it. Okay. That is accurate and precise, better. Precise is, every time you're cutting 4 feet, 4 feet, 4 feet. They want 5 feet, but you're cutting 4 feet every time. Okay. They want 5 feet, but every time you're giving them 4 feet. So this is not accurate, but precise. What it means is, probably the reading that you have given in the machine is wrong. If you adjust the reading, your process is set. So you have to adjust the reading. It is probably the reading is bad, that's why you're not able to cut it. Maybe, the operator has given 4, right? That's why it's cutting 4. Okay, you have to adjust it and it will work fine. Okay, but not precise, but accurate means what? It means that once you give 4 feet, other you get 6 feet. You don't know what is happening to the process. You don't know what is happening to the process. Maybe blade is loose, sometimes it's cutting this and that. Here, it will take more time and effort to fix. So, process which is precise, okay, I'm talking about most of the time. Most of the time, the process is precise but not accurate. It is easier to fix. Most of the time. But if the process is accurate but not precise, it can be difficult to fix. What can you do if I come at 6:45 and 7:15? If I come every time at 7:15, then okay, you log in at 7:15 only. But if I come 6:41, then what? You can't do anything. Right? So that is very bad. So precise is still better. Okay, accuracy is difficult to fix. So of course, between precise and accurate, we prefer precise over accurate. So precise comes from standard deviation. Precise means less deviation. Precise means very less deviation. That means standard deviation is 0. Your standard deviation is very good. Very good means 0. Almost close to 0. right? If the standard deviation is 0, the histogram will be a one big line. It will not be a spread, right? 0. That means every time you're getting same value. Every time you're getting same value. It will not be a spread. Okay. So talking about precise. Precise means standard deviation is less. Accurate means your average is same. If a process is accurate, that means your average is same. Right. Now, if you take this example that we discussed here, in this case, all three processes have same average. Yes or no? So accuracy is very high, but it is not precise. Okay. This one is accurate and precise both. Okay. So your precision comes from standard deviation and accuracy comes from average. Okay. So let's talk about delivery time. Let's say you are comparing two restaurants. Okay, two restaurants, and you're going to. So if you see the average, what you did is you are looking at the data of the delivery time. So the time at which the order came and time when the order was delivered. Okay, and you do have lots of data, right? You have 1,000 data, and you perform average and standard deviation. So when you perform average, okay, you get everything is getting 20 minutes. But when you perform deviation, which one has the higher deviation?
First one.
First one has
Higher deviation.
higher deviation. Now, if you want to spend more time at the restaurant, which one you will prefer?
The second one. Second one we should.
Okay. If you want to spend more time, okay.
Go for first one only, I think, because they have high variability of delivery times.
Yeah. So see, high variability also means that sometimes you get food very fast also. You go and sit and say food is ready. Variability is both the side, right? Variability is not only one side. Okay, had it been long tail, like you're positively skewed, then you say that, okay, most value is on the right side. Okay, but here, first case, you are not sure how much time it can. Sometimes you might get food in 10 minutes, sometimes you might take 30 minutes to get your food. But here, you're sure that you are going to get around 20 minutes, not 15, not 25. So probably if you want to spend time, this is better. Okay, half of the time you may not get time to spend, but other half of the time you'll get lot of time to spend. Here you are very sure that you're not going to get more than 20 minutes. Short time. So if you have lot of time, go here. But you're feeling very hungry, second one. Okay, you don't want to wait, so you go to the second one, right? This is investment. So investment also, we want investment which is more precise, right? So we prefer one. So between these two, tell me, this is investment that you made this is the first investment. Okay, let's say again you have some money and you want to invest somewhere, and you have two options. Okay, you have two options and you want to decide whether to invest in A or B. You look at this, tell me which one will you prefer, A or B? And of course, answer is Y. Okay, you have two options. So you look at the history and you draw the histogram, and now you're deciding which one to invest money in. A, Y. What is more number of less value? All the numbers are there, no? Read and tell me, no. Don't tell me more or less. First, look at the range. In A, you see, minimum value is minus 30. That means you can get a loss of 30%. The
Yes.
maximum is
75.
75. Okay, you can get somewhere around 75% return on the higher side. In B, you see, maximum is minus 40. Okay, and
Okay.
this is also 75, close to, right? As you can see in B, okay, you have these values, you see before 0, okay, you have 45. But bulk of the values are on the positive side. Bulk of the values are on the positive side. But on the negative, there is also minus 45. But in A, you have less negativity, right? Maximum negative is only 30. But if you see, more values are on the negative side than compared to B. So if you are a risk taker, you'll prefer B. B, because positive thing is also high and negative is also high, right? Like stock market, if you're a risk taker, you will go with B. But if you don't want a risk, no, I don't want to take like 45% risk, negativity, then you will go with A, right? So A will indicate that you don't want to take risk. You want to play safe. B is more like high negative also, high positive also. Okay. So if you are a risk taker, you will probably prefer B. Okay. Correlation we have done. What is correlation? What is correlation? Relationship between two variables, right?
Yes.
One is on x-axis, one is on y-axis. Okay. So yeah, we don't have to discuss. So this is how you calculate R square. R square, okay, is called it is a variance 1 minus variance of fitted line by mean line. Okay. So we'll postpone it to data science. Okay, we'll talk about data science because before that we don't know what is fitted line. Yeah, so we'll do fitted line and regression, and then we'll talk about R square there. Okay. So this is how you calculate. So with that, we finish our statistics discussion. This is your descriptive statistics. Okay.